Hello, you two vintage stereo collectors. I know what you're thinking. Why is he doing another Kenwood? Another boring Kenwood. Well, actually, these are nothing but boring. Or anything but boring. I don't know. Whatever. The reason I'm doing this one, I just recently got this. And based on feedback from people that watch this channel, some people would like to see a little bit of a slower stage-by-stage approach on these restoration videos. And this amp really lends itself, if you understand the design layout and how to restore this small one, anything from the same era, late 60s through to late 70s, is very similar. Whether it's a quasi-complementary with metal transistors or a full complementary, whether it's capacitor outputs or non-capacitor outputs, very similar. The power supplies are similar. There's only a couple variations. And this one, I took it apart and I was so surprised at how clean it was inside. The top cover is damaged. That's why I got it for such a good price. But I can fix that, a hammer and a block of wood and some paint. Right here, the bottom of this, it's all original parts. Nothing's been touched on this one. This was used and then they got something bigger or moved or whatever, and then they moved on with life and got something, usually went bigger, maybe went to a digital tuner receiver. But regardless, this is a great model to kind of figure it out. What I'm going to do, we're going to power this up. I'm just going to show you how to assess these. Here's an input from a tuner that's just offside. Plug that into tuner. And I reach over for my handy dandy headphones. I prefer to listen to headphones. When you hook it up to speakers, there is the risk, I've had this happen, where there's a blown transistor and you get like 40 volts right out on the speaker. It's rare, but it happens. We'll plug it in. It's plugged in. And I don't flick it on with this on my head because you could get a noise, a good crackling. So let's turn it on. We got a dial light and everything. Let's just see what we got. I've got sound, clear sound, both channels. Very, very stiff controls. Loudness work. Wow. There isn't any play or crackle in this volume control. This thing was hardly used. This was hardly, I mean, it's kind of dirty on the front, you know, from being handled. But this does not have a lot of hours on those controls. What I'm going to do is a quick little thing that I do, and careful I don't touch the wrong thing. Right there. Let's just do a quick look at voltages around the chassis. It's not overheating or smoking. The outputs are cool. I'll just go on ground. Go on the main filter cap. 40.3 volts. That's what it's supposed to be. And then this one here, 17.7. So it's supposed to be 19. It goes to the phono board, the tone control board. It's for the low, you know, the small signal stages. Over here is what I wanted to look at. Every amp of this vintage solid state amp has emitter resistors. There's the odd exception. I did a Muntz 8000 recently and there weren't any emitter resistors in it. And it worked fine. But anyway, they're there to protect the transistors. So what you want to do, you'll want to find the two emitter resistors that ground to a common point, and then put your meter there so you can see it. I am going to go and touch the contactor there. 49 millivolts approximately of current draw from the bias circuit through the output. Here's the other emitter resistor, 64.7. Those are both a bit high. It's supposed to be about 14 millivolts, which represents 10 milliamps of current flow. It is a bit high. They'll eventually get pretty warm. But this is what happens. They drift as they age, especially with the type of bias controls you have here. On these older ones, the bias controls were a weak point. What I'm going to do is just put it down again. Hopefully you get a good shot of this. It's a good day because there's sun outside for a change. Right there. So those are two bias pots that bias the outputs. Those two are the center voltage, the single rail power supply. So you basically have a baseline voltage, which is 0. That's what the center voltage. And then you have the one transistor swings this way and the one swings that way off the baseline. Then you have the protection circuit, and there's a setting for each channel. We'll go into protection circuits later. This one does not have fuse or circuit breakers or anything. There's one fuse on the primary winding of the transformer. That's all this has. Very simple design. It's kind of interesting. I have had, this is number 32 of this model that I've owned since 2005. And anybody that's bought one, and actually one of my offspring has one, and it's been going like 6 years. And these go and go, and they have warm sound, and they are a punchy, heavyweight amp. So I know it's only 12 watts per channel, but they really go. But what we'll do is we're going to do a kind of coverage of things. What I'm going to do next, we're going to take these outputs off because they're probably dry. They need to have silicone grease behind them. Take those off, re-grease them. We'll change these bias and center voltage pots out, and we'll get the output sitting where it's supposed to be, around 14 millivolts, and then proceed to the power supply. Anyway, thanks for watching and listening.